So in this picture here, how many people think that this is Pluto? No? Okay, what about Earth? Think this is Earth? See like
Yeah,
odd?
I think it is.
Think it's Earth? Okay. What about just somewhere else? Anyone think it's somewhere that I haven't mentioned?
I'm gonna go.
Mars.
I'm gonna go Mars, just to be contrary.
Okay. Okay, that's fun. I saw Gary, you raised your hand.
Yeah, someplace else.
Okay, someplace else. All right, so we've got a range of answers. This is Earth. Those of you who had that hunch were right. So here on this blue marble we live on, we're lucky to have these sheets of ice at our poles, and they're made of the best ice for life, which is water ice. Um, so that picture was actually a picture of ice at the North Pole. So ice on Earth is pretty incredible. It changes the seasons. It melts into the oceans, it refreezes, and this all depends on the temperature and the sunlight, and the complex thing that is our atmosphere. So the water cycle on Earth is pretty complicated. There's a lot of factors that go into how things change. Ice can move and break, follow gravity. Ice and water, if it's not, can flow. So, like glaciers themselves grow and retreat depending on ambient temperatures in the atmosphere and the temperature on the ground. But the thing is, ice is such a tiny, tiny part of our planet. So, ice is a very thin veneer on our planet. We've got this diagram of Earth here where you can see we've got Earth's inner iron core, the mantle, the outer core, all of this stuff that's basically rock, um, different kinds of molten rock and metal. And then there's Earth's crust, which in this picture already isn't to scale because Earth's crust is very tiny compared to the rest of it. And so that's more rock. And on top of that top layer of rock, we've got this even thinner sheet of ice. So even the thickest ice sheets are only around 1,000 meters, which compared to the crust, which is almost like 6,500 kilometers, that's a very tiny fraction of our planet. So what if, instead of ice being this small feature, there was a whole world made of ice? And you might have an idea where I'm going with this. And that's because there is one. Pluto is an entire world made of ice. So now that we've reached the outer solar system, we're exploring this whole new class of small bodies that are composed of mostly ice. And they're not just boring chunks of ice. They have interesting active surfaces with this icy geology just starting to get to know. So this is a diagram of Pluto to compare to what we just saw for Earth. So Pluto does have a rocky inner core. We think it has a liquid water layer, so a subsurface ocean, kind of like Europa and Enceladus, but much deeper down. And then the bedrock of Pluto is really this thick shell of water ice. And the veneer on top are other more volatile ices like nitrogen, like dry ice, um, that on Earth really evaporate suddenly, but in the very, very cold temperatures of Pluto can actually be more stable. So Pluto is a really interesting body and it's made of ice. It's active, so the materials on its surface are moving and changing, which is something we really didn't expect before the Horizons mission. It's very different from Earth, obviously. It's an entirely different, temperature range. It doesn't have the same kind of atmosphere. It's a whole different ball game. And it's part of the Kuiper Belt, so it's really part of this far out edge of our solar system beyond the orbit of Neptune. So it's almost 5 billion miles away from us. And it's not a planet, and we will get to that later because usually the is Pluto a planet debate always comes up. So we will talk about that, I promise. Um, but really, how do we know anything about something that is so far away? 5 billion miles is far. We know that it's hard enough to get to Mars and harder to get to the outer solar system. How do we get to one of the furthest things in the outer solar system? And so we'll go back in history a little bit. So Pluto was originally discovered in just a normal ground-based telescope. It's this very, very tiny dot you can see in this image. There's arrows pointing to it, how it's moved over the course of a few days. So it was originally discovered by a man named Clyde Tombaugh at Lowell Observatory in Arizona, where he noticed the motion of this tiny dot and that it was moving faster than something outside of our solar system really. Um, So it was discovered in about 1930. And we didn't really get much better images until Hubble launched. So then astronomers finally got to use Hubble to get a better look in the 90s and early 2000s. And so before New Horizons, this was our best look at Pluto. You can see the image on the upper left. You've got Pluto and a couple of its moons that are clearly resolved, but Pluto itself is still just a bright dot. It doesn't really look much different than how we see a star through a telescope, except for the fact that it's got that disk. And this other image on the bottom right manages to resolve some light and dark spots. But that's it. That's all we knew, that it was a slightly mottled globe. People could figure out its basic composition. We knew it was made of a lot of nitrogen. That would have to be ice at that temperature. But this is really what we knew. And then our whole understanding changed so drastically when we finally got the New Horizons images, which you may have seen, and they're gorgeous. So we have so much data from New Horizons that has entirely revolutionized how we think of Pluto and their outer solar system. So the mission itself was launched in 2006, and then it took almost 10 years to get to Pluto because it's so far away, and did its flyby in 2015. So this was the first mission to Pluto and the first directly to the Kuiper Belt. The Voyager missions passed through the Kuiper Belt, but didn't actually, stop by to see anything because of their trajectories. So it traveled, I feel like typo. I think it's 2.4 billion. I could be wrong though. So it traveled millions and millions of miles. And it had 7 different instruments. So the New Horizons mission not only took the pretty pictures that we see, but it also had instruments that could take spectra to figure out composition, and even some really cool things like this radio instrument that actually was able to look at the atmosphere in more detail, and an instrument designed by students called the Student Dust Counter that tried to track how the density of dust changes as New Horizons traveled through the solar system, so it's still collecting data. And because it was so far away, it took 16 months to transmit all the data. So that means that we didn't even have all the information from the telescope until about mid 2017. Yeah, mid 2017. And so, science takes a long time. People are still looking at this data and still finding out new things from it. And New Horizons is still out there and going further away, going the way of the Voyager probes, where it will continue on after it did its flybys. Yeah, oh, good. My instinct was right. It is billion, not million. So this is a diagram to keep track of sort of where New Horizons went in space. It started from Earth, did a bunch of flybys, to get that gravitational boost. And it really this took a lot of time and a very long journey to get there. I really like to show this picture just to think about how difficult of a thing this is to do. So we're sending something 3 billion miles away to intercept a world that is only like thousands of kilometers across. That's a really crazy problem. But it worked. It worked magnificently. And it was so hard that when everyone came, like when the data finally came down successfully, people were thrilled. So this was before I joined the mission. I joined when I was an undergrad in about 2018, so I wasn't there for the actual flyby. But I love seeing these pictures of the team so excited. Like, this is one of my favorite parts of NASA missions personally, is just getting to see all these people that, they're basically like friends, and they've this really cool, momentous thing that they've spent large chunks of their life working towards. And now I can, spot my advisor in those pictures and stuff too, which I think is fun. So everyone was very excited when this data came down, and it was all over in the news. It was described as a toy store for scientists, just because there was so much data to look through that was just worlds beyond the quality of data we'd had before on Pluto. So if we've looked through all of this, we actually learned. It's been, a couple of years since the flyby. We've got to have some science results by now. And before I go on, I just want to say, if you have questions at any time, feel free to interrupt me. I'll open the chat window just in case anyone puts a question in the chat. Yeah, feel free to interrupt me at any time, even if you're just curious about something. So, all right, let's get into what we found about Pluto. So we're going to take a tour of this ninth wonder of the solar system, figure out just what scientists have learned about Pluto. So we're going to take an approach that is called comparative planetology, where we're going to ask questions we would ask essentially about any planet. So as we're going through, we want to imagine how the answers to these questions would be different on Earth. So comparing what we know on Earth, in greater detail from in situ observations where, we can actually like go to the North Pole and measure the ice. Comparing those kind of observations to remote sensing data, like what we get from a probe, is a great way to try and help understand what actually is going on geologically. So comparing different planets is a way for scientists to understand what processes are happening, what they have in common, and what's different. So usually we'll try and find features that look something like Earth and say, okay, like, is this actually the same thing or does it just kind of look the same? And sometimes things are just a puzzle and no analog on Earth. So we'll see a bunch of those. So first off, what's Pluto made of? You might know the answer to this now, which is ice. Lots and lots and lots of ice. So these are real images from New Horizons of ice on the surface with big craters and icy mountains. It's made of a couple different types of ice. So its surface is made of mostly nitrogen ice, with some methane and carbon dioxide ice, so dry ice, and bedrock is really water ice. So the images here are from the spectral information I mentioned we have, where by looking at what wavelengths of light were absorbed by the surface, we can figure out what molecules were on the surface. So we've got methane, which is just about everywhere, nitrogen, which is just about everywhere, and it might look like there's less nitrogen, but actually just because of the way that nitrogen absorbs light, it's a lot harder to see nitrogen in this kind of data. So if we see a little bit of nitrogen, that means there has to be a bunch more there. So we've got a lot of methane and nitrogen, a good smattering of carbon monoxide all over. And then there's this patch of water ice. And you might be wondering, I said that water ice was the bedrock, so why is there only water in this little patch? And that's because this kind of data is only looking at the surface. So this is where water ice is exposed and the other things aren't on top of it. So that means that this methane, nitrogen, and carbon monoxide ice is sort of acting like snow that moves around on the surface. And then the bedrock underneath it is that water ice. So this big patch here where the water ice bedrock is exposed actually has a name. It's called Cthulhu Regio. All of the Pluto names are very fun. We will definitely talk more about naming. And so this is a place where there isn't really any snow. It's a hot spot, and so the bedrock is exposed. Question number 2, does Pluto have an atmosphere? Shockingly, yes, it does. So it's got an atmosphere that's mostly nitrogen with a little bit of the other gases that are present as ice on its surface. It is significantly less dense than Earth's atmosphere. It's very, very tenuous. But it also has some of these complex compounds. Sometimes some of them are organic compounds. And so there are things that are formed from sunlight hitting these molecules in the atmosphere and making complex chemistry happen. Pluto is much, much, much colder than Earth. So surface temperature is 42 Kelvin compared to Earth's nice about 288, which is on average around like 30, 40 degrees Celsius. And Earth's atmosphere is much warmer. Pluto's atmosphere is super, super cold. Really, everything on Pluto is freezing. In the atmosphere, though, we also see these really cool layers of hazes. So those are the organic compounds that I was mentioning. So there's all of these different layers that New Horizons observed. They actually found 20 defined layers of hazy particles that were scattering light, some of which were over 200 kilometers off the surface, which is pretty wild for something as small as Pluto. This is personally one of my favorite images from New Horizons. I think it's absolutely gorgeous. So our next question to tackle is, what is Pluto's surface like? Are there any cool features or geology? So now we're going to go through and I'll highlight something on the big globe so we can think of where things are, and then we'll look at it in more detail. All right, so first off, we're going to look at craters. So that's Elliott Crater here on the big map, named after Jim Elliott, one of the pioneering Pluto scientists of the 20th century. And we've got these craters up close. So these are all craters on Pluto. This is Elliott Crater again, up close. You can see it's got a little raised bump in the center, which we know many craters have. I'm seeing on other planets. And Pluto's pretty heavily cratered all over, which makes sense because it doesn't really have enough of an atmosphere to stop things from hitting it. And we definitely see craters on Earth. This is one of the easiest to identify features on Pluto's surface. So an Earth analog of this would be something, you know, like Meteor Crater in Arizona, big impact basin. I gotta plug in my computer. Cool. Sorry, it ran out of battery faster than I expected. So we've got Meteor Crater in Arizona. Has anyone actually gotten to visit your crater? It's gorgeous and not too far from us.
Yes.
I got to go when I was visiting grad schools. I thought it was so cool. All right, cool. Computer is charging. We're all set. So our new feature. Oh, there we go. Image load. So now we're going to look at some mountains. So these are called the Barre Montes. So just, you know, geology words for mountains. One thing I learned is in my time doing, you know, planetary studies is that there has to be a fancy name for everything. And also that naming things in astronomy actually takes a really long time because of the International Astronomical Union. So most of the names of features I'm going to say about Pluto are technically considered informal names. They're the names that the scientific community is using, but they haven't been officially adopted by the IAU yet. And that'll make more sense when we talk about Pluto's moon trend. For now, let's look at mountains. There's some mountain ranges on Pluto. And when I say mountains, these aren't the typical Rocky Mountains we think of. They're instead really giant chunks of water ice. So water ice, like I said, is the bedrock. So it's the thing that's actually forming these mountains. It's almost like they're giant icebergs that are like floating on the other ice. And there's quite a few. We see these really complex ranges. And again, we think of them similar to mountains on Earth, but they form totally differently. Unlike the plate tectonics we've got here, there's multiple different ways you can get mountains on Pluto, we think. And the other thing that's really different is how snows happen on Pluto compared to on Earth. So on Earth, we get snows on the top of the mountains. We get snow-capped mountains by warm air going up. And then because it's cooler up there, it cools and it condenses onto those mountain peaks. Pluto things actually happen differently. So the air is warmer on the top, and then it will end up flowing down and condensing on it. And the surface is much colder, and the atmosphere is much drier since things have condensed out on the top. So whereas on Earth, we get snow-capped mountains from air moving up, on Pluto we get it from air moving down, actually. All right. Our next one, this is a feature called a fossa, which is basically like a canyon. So we see these ridges, these cracks that at first glance kind of look like something that could be carved by water. And I don't think we've really established yet whether we think that these are cracks from tidal forces, so from Pluto's moon Charon pulling on it, cracking the surface, or if they might be from some, you know, warmer, watery, you know, motion on the surface. Because it seems like Pluto, when it gets closer to and further from the sun, actually does have a lot of seasonal changes. And so an Earth analog is, of course, the Grand Canyon, but it seems like this kind of running water feature wouldn't really be as common on Pluto. All right, and then this is a weird one. So this area on the limb of Pluto is something that astronomers have been referring to as the bladed terrain. And so this one was a really big puzzle for a while. It's got this weird, you know, sort of spiky, rough-looking features. And it turns out that someone came up with a great explanation, which is that these are something called penitentes. These are found on Earth in places that are very cold and very dry. So found in like the high deserts of Argentina. Um, and they're basically just these giant person-sized ice spikes that form. So that's what we think the bladed terrain is. Then let's see, we got another one here. So this doesn't look like anything on the big map, but when you zoom in, we see these features that look like they could be frozen lakes. And we know that the big heart shape on Pluto is actually a big reservoir of ice that does fully convect. So we've got these smaller versions. And it really does just look like a frozen version of Earth lakes. So it's really interesting that we spot those things on Pluto. Now, I mentioned before that Pluto's surface does change, which came as a bit of a surprise. Like for something that far away from the sun, the question really is, how does it get enough energy to actually move? There needs to be some warmth, there needs to be some heat. And one of the biggest drivers of change is sunlight. It's just that these ices are more volatile at the temperatures and pressures of Pluto than they are on Earth, so they move a little bit easier. And one of the biggest features with most motion activity is the heart of Pluto. So the heart of Pluto is actually two different regions. One is Sputnik Planitia, the left of the heart shape, and the other is Tombaugh Regio, the right of the heart shape. So Sputnik Planitia is the really, really interesting one. So it's this big crater that's been filled with nitrogen ice. So it's a super deep basin with this ice that convects. There's little pits on top that we think are from sublimation, and it's got glaciers that move and interact with those mountains on the edge. It's a really cool place. We've gotten the high-res, really neat pictures of it. So this on the left is a zoom in of the left of that heart shape that we saw, and it shows the convection cells where there's material that is coming up in the center of these cells and going down at the outside. This is a picture of the edge of Sputnik Planitia, where you can see that that nitrogen ice from Sputnik is flowing into the mountains and the other cratered terrain at the edges. And then there's all of these convection cells in the center. There's also, like I mentioned, even smaller features. So these are those big convection cells again. And then on the top, there are all of these little like sub-kilometer sized pits where some ice has, actually just sublimated away and left a little indentation. So this is proof that there's sublimation going on the ice of Pluto. And our last geologic feature for now, a little mystery at the bottom of Pluto that doesn't look like much on the big map again. When you zoom in, it's this very weird divot that kind of looks like a volcano. And so people are investigating this. It's called Right Mons as a possible cryovolcano, so an ice volcano. And then another place that is an indicator of change Pluto is, like I mentioned earlier, Cthulhu Regio, so that band of where the water ice is exposed. So if we look at this image of Pluto, we might intuitively think, okay, well, the top must be the North Pole and the bottom must be the South Pole. But because of the way that New Horizons did its flyby, what we're actually seeing is the North Pole of Pluto is where I put that circle with the X. So Pluto's a little tilted towards us. So Cthulhu Regio is actually right around the equator. And so because of the seasonal change, you get more ice on the poles, and even in these mid-latitude bands that you see right next to Sputnik Planitia. And modeling has shown that we expect this dark band of Cthulhu Regio that we see. So you might be wondering, how is that ice actually moving? And it turns out the main driver here is really just that sunlight. So what happens is where sunlight hits, things warm up and the ice sublimates. moves around the atmosphere, and then condenses somewhere colder. So where the sunlight's not hitting, you get condensation. Where the sunlight is hitting, you get sublimation. The seasons aren't quite straightforward because Pluto has a really funky orbit. It's eccentric and it's tilted, so it's inclined compared to the rest of the planets. So whereas, the rest of us just go in nice, neat circles, Pluto's just totally out of the plane of the rest of the planets. So it has a much more complex seasonal cycle, even with something called super seasons, where there's like larger scale ebbs and flows to its seasons. And there's been some really interesting modeling work done to understand how that ice changed and what would have happened to get it to what it looks like now. I mentioned that Pluto has a moon. It's got a couple buddies. And its biggest is Charon. So Pluto has 5 moons, Charon's the largest, and it's so large that sometimes people like to call Pluto a binary planet system because Charon is almost the size of Pluto. There's also some interesting stuff going on Charon. It doesn't seem quite as active as Pluto. It has this very huge chasm across the center, which really just looks like it's been split in half. I think is probably from tidal forces. And then it's also got this really dark spot on the top. It's a fantastic name. It's called Mordor Macula. And the entire naming scheme for Charon is actually pop culture sci-fi references and fantasy references. So there's a Leia crater and a Luke Skywalker crater and a bunch of fun stuff. And I love that they named the dark spot Mordor. So we think this dark spot on the top might be from some of those hazy particles in Pluto's atmosphere getting deposited onto Charon. And Charon is made of rock and ice, just like Pluto. The other moons are much smaller. Only 2 of them we managed to spot with New Horizons just because of how orbits were at the time. So we've got some nice higher resolution images of Nix, one of Hydra, which is a lumpy captured Kuiper belt object looking thing. And then Kerberos and Hydra Kerberos and Styx, we've only seen with Hubble. We didn't actually manage to spot them on Horizons flyby. Given the names Pluto, Nix, Hydra, Kerberos, and Styx, can anyone guess the naming scheme for that? What do they all have in common?
Underworld?
Yeah, they're all mythology of the underworld. This is one of my favorite things actually about solar system science is that there are really cool naming conventions for all of the different planets and their features and the planets' names themselves with the moons around them. So like Uranus has moons that are from a couple of Shakespearean plays. It's really fun to look. Pluto's got the underworld moons, and we got to see that these guys were pretty much what we thought they were, which are little Kuiper belt objects that got captured by Pluto. Now to the big issue, the elephant in the room when anyone talks about Pluto. Now that we know all that we just learned about Pluto, does that change anyone whether or not you think of Pluto as a planet?
Hey, I like Pluto.
Me too. I would like to say you can like Pluto and still think it's not a planet. Y'all might know this is a pretty popular. Oh, go ahead.
Considering what we found with New Horizons, it's a very active body, which in my mind classifies it more with a planet than a minor planet.
Yeah, so this is a great point. And actually, activity isn't in the IAU definition of a planet. So really this all comes down to an argument about what words we choose. And it became a pretty popular issue. People, especially the internet, got really worked up about this. Like books were written, memes were made. Still to this day, like when I go give a larger talk on Pluto, I'll inevitably get like some mom and kid being like, why did you kill Pluto? And I'm like, I don't know what to tell you. I was 6 when they demoted it. I had no hand in this. And like the decision was made by the International Astronomical Union, and it was really just based in this change of what the definition of planet is. So rules for planethood are, first off, a planet is something that orbits the sun. Check mark there for Pluto, all good. 2, a planet is in hydrostatic equilibrium, which just means it's big enough to be round. And Pluto's also good there. Rule number 3 is the one that got it. A planet is something that has cleared the neighborhood around its orbit. So Earth, for example, doesn't just run into asteroids and stuff. It doesn't have a bunch of asteroids in the same orbital path around it, around the sun. Pluto has not done this. It is within the Kuiper Belt. So Pluto is one of these Kuiper Belt objects. It goes through the Kuiper Belt. It wasn't big enough to use its gravity to kick all those things out of its orbit. And so, although astronomers do need to have a good definition for planet, I think this debate sometimes takes away from when we talk about Pluto. Like, does it matter if it's a planet or not? No, we know that it's active. We know that it's interesting. And plenty of things are active that are not planets. Like, for example, comets are very active. They're emitting large tails of gas, but they're not planets. So I think we should really just focus on how cool this little world is, planet or not. And I usually just refer to it as a Kuiper Belt object because that's what it is. It's one of the largest Kuiper Belt objects, or the largest. But it's one of these little icy bodies that's out beyond Neptune that can really tell us a lot about the beginning of the solar system. It's a cool, both figuratively and literally, place to be. And really, one of the reasons that Pluto got demoted was that there were all of these things that, based on the old definition of a planet, would have also had to be called planets. So if we considered Pluto a planet, then we would have to give all the other things that are like Pluto planethood. And I think everyone just thought making kids memorize 16 planets seemed like a little harsh. And so all of these guys here are dwarf planets in the Kuiper Belt instead of being actual planets. So we've got Pluto, and then some of the biggest, most famous ones are Quaoar, Sedna, Haumea, Makemake, and Eris. So these are some of the other dwarf planets that are out there. And so after Pluto, New Horizons kept going. So it ended up making its way to a new target because the team found that they could actually steer the spacecraft to a new target. They had enough fuel left. So they ended up going for another smaller Kuiper Belt object to get a sense of what's out there besides Pluto, the biggest one. And so they ended up going to a world called MU69. It looks more like what we think of as an asteroid. You know, it's small, it's lumpy. And this was the first Kuiper Belt object other than Pluto to be imaged in that kind of detail. So this is an artist rendition, but I will show you the real pictures, I promise. And New Horizons got wildly close. They got within 30 to 100 kilometers of this tiny object, which, considering that this is a absolutely tiny rock that's even further than Pluto, that is again a wild feat of engineering. Because it got so close, we were able to take images that could see down to detail of about 100 to 200 feet on the surface. So this is so far the most distant object that we have explored in this kind of detail up close. And so MU69 is pretty neat. What we've got here, there's just a still image of it in color, and there's this black image of it that is in stereo. So it's these images that have been taken as the spacecraft was flying by in order to give you a better sense of shape. And so MU69 ended up being this like flattened snowman shape. So although it looks like it's just two balls sitting on top of each other, they're actually more like two pancakes that are stacked on top of each other. And it's pretty uniform in color. And this is what we call a cold classical Kuiper Belt object, which really just means it's a well-preserved specimen of the early solar system. Cold classicals are things that haven't really been thrown around the solar system much. They're basically where they formed, and they've been there forever. So its shape actually tells us about how it formed. In order to make something like this, where you've got the two things pretty much intact in this shape, you basically had to have the two rocks gently collide after orbiting each other and spiraling in. So they were actually going pretty slow when they collided and they connected. And so this gives us evidence for one model of planet formation over another. So two of the ways that we think planets have formed, one is something called cloud collapse, where you've basically got a big cloud of gas and dust and bits of it collapse to form things. Hierarchical formation means you've got a bunch of different rocks, and to make big things, they crash together. So this is actually evidence for cloud collapse because you have two things that must have been near each other by a collapsing cloud and then just slowly come together. So looking at Kuiper Belt objects actually gives us a window into the early solar system. And so the big takeaway here is the outer system is cool. It's really interesting. It's a place to do a lot of really cool science and to understand really where we came from. So I hope to convince you that Pluto is really worth exploring. The New Horizons mission did some really cool stuff. And I am happy to answer any more questions y'all have. I hope that was fun.
Thank you.
Thank you. That was great.
Yeah,
I have a
thanks.
question. This is Laura. I don't have my face on. I'll put my face on. Here I am. So I had two questions. Whoops, and I went off. I'll put myself back on, maybe. So one is, it looked like Pluto's orbit was not really with the Kuiper Belt in your cartoon. It looked like it was not, you're saying it's part of the Kuiper Belt, but looks like an orbit is not. Was that a correct cartoon?
Yes, here I will show it again. Where'd my window go? Let's see, there we go. All right.
There we go.
You see it now? Okay.
Yes.
Yeah, so Pluto is in the Kuiper Belt. So this, I get how this is confusing. This is a little bit of a confusing picture. So Pluto looks like it's not because it's inclined, and here the Kuiper Belt looks flat. The Kuiper Belt's not actually flat. There are things that are out of the plane like Pluto. So really just think about like how Pluto, goes through the Kuiper Belt. And yeah, I think this is not quite to scale. It's just an example.
So there are other Kuiper Belt objects that are also in odd tilted orbits compared to
Yes.
the rest of the plane of the solar system.
Yes, there are a lot. And actually, people observing very inclined solar system objects is what led researchers to think that there might be a planet X out there, a planet that we haven't discovered yet, that is, nudging some of these Kuiper Belt objects into these other orbits that are even more tilted than Pluto's. So it's definitely more complex than that cartoon showed.
And that idea of Planet X has not been dispelled yet.
It has not been dispelled yet. There is a lot of debate about it. They also haven't found it from looking, but there's a lot of space in the sky to search. So it's like finding a needle in a haystack. So I know the original, proponents of Planet X have not given up yet. They're at Caltech and they're still very much looking. And no one has really given definitive evidence that it couldn't be there. So it is very much an active debate.
Okay, I have a second question. Excuse me. Which is, do we know the mechanism that's causing those convection cells on Pluto?
I'm pretty sure it's just heat that's trapped in the core from when it formed. So you've got this heat that's the latent heat under the surface, and so that combined with the sunlight heating up the ice. Water has a pretty high specific heat, so it's going to retain some of that heat.
And why is it hotter in the higher atmosphere than below?
That one I actually don't know. I haven't studied Pluto's atmosphere enough. I was the surface geology person. That is a great question, though. I'm pretty sure there's a paper on it. I just don't remember, to be honest.
Okay, great. Thank you.
I have a question.
Yeah.
How did you get into this? Did you know that you were going to become a Pluto surface geology person?
So this is actually not what I do now. I do other planetary science stuff. So when I started undergrad, was like, I like space. And my parents hadn't been to college, so I didn't really know what to expect at all for college, let alone astronomy. And so I ended up in this because I thought it looked cool. I applied to work on it and I ended up getting it. And then that started, essentially a love of the small rocky stuff in solar systems. And so now I work on other things. I'm currently working on a project about Europa, Jupiter's icy, subsurface ocean world. Um, and then I also work on things called debris disks, which are like Kuiper belts, but around other stars. And some of them are from solar systems that are earlier in their history. So they're like baby solar systems. So we can see how planets form from how all of that dust and all those chunks of ice and rock move around. So yeah, I kind of ended up on in the, just like life is funny fate kind of way. Like the project presented itself and I thought it was cool. Yeah, I don't really have a better answer. That's kind of how it happened.
Very cool. Thank you.
Riley, I have a question. So on the one hand, Pluto is not a planet because they said it didn't manage to clear its local neighborhood, right? But yet, on the other hand, it's an object that managed to aggregate enough material to end up being 4/10 or 40%, I guess, of the mass of the Earth. That sounds like it cleared an awful lot of stuff, doesn't it?
Yes and no. So it may have accreted from a bunch of stuff, but the point is that there's still things around it. So it's not how much did it absorb it into it, it's is it large enough to kick all the other things out. So like Earth, basically like, slingshotted asteroids and stuff away from it. Pluto is unable to do that. So that's really the distinction. And yeah, Pluto wasn't even big enough to like carve a big gap. So you can think of that as another way where like if something is accreting a lot of material, like for example, when a Jupiter-like planet is forming, those are so big that they carve an entire gap in the disk of dust that's forming planets. Like we've seen that in other solar systems. That is not something Pluto would be able to do. It is far too small. So it's really just like a technical way of defining its size.
How does it compare in size to Mars?
Definitely smaller. I don't know the exact number, mostly because I don't know what size Mars.
Not much, though.
It's less than half, I'm pretty sure.
Oh, really? Okay.
Yeah.
So,
I gotta let the puppy out. 1 second.
Thank you.
Go ahead, Bob.
If I'm not mistaken, Dan, I think that Pluto might be even smaller than the moon.
Yeah,
Really?
I'm pretty sure it is.
Yeah, it's very small.
so adding on to what Dan was saying, is it possible that Pluto just hasn't had enough time? Because I mean, it's so far out to make so many orbits to clear its path that it just hasn't had the time to do so.
No, so you can like simulate that with n-body simulations where you've got, a bunch of different things around each other. And it wouldn't do that. Like we know that. Other things would happen in the intervening time. Like you could get nudged by other things or there could be collisions, but that's basically not really a possibility in the time of the solar system. Yeah. And I just checked. Pluto is in fact smaller than the moon. The moon's about 1,000 miles in radius, and Pluto is only about 730 miles in radius.
Oh, wow. Okay.
Yeah. So it's really little.
Did you say where New Horizons is going next?
So they don't have another target. There was not another one that was feasible to navigate to after MU69. So it is pretty much just heading out further out into the solar system, just like the Voyager probes did. And I think if there happens to be another thing that they could reasonably navigate to, they would try, but the further out it gets, the harder it gets because we're now into territory where we can't really even see with Hubble some of these small objects. So it'd be really hard to navigate to them. Like even getting to MU69 was really hard because of the fact that, you know, if it's something that's only been seen in Hubble images a few times, like MU69 I think was discovered in 2014, I want to say. So it means we only had like 5 years of its orbit. And because of how far out MU69 is, its orbit is hundreds of years. So trying to figure out exactly where something will be when you only have 5 years of a 200-year orbit is really difficult. So I'm amazed that we could do it with MU69. And so the things further out, we have maybe like 1 or 2 data points on. So actually knowing exactly where they're going to be is really difficult. And just the further away, the fainter it is and harder it is to see. So right now, New Horizons is just chugging along, not going to anywhere in particular.
So is the Kuiper belt kind of flattened, or is it more like a halo or spherically shaped, or?
It's kind of flattened. It has some things that are eccentric. The sphere around us is really the Oort cloud. So the Oort cloud is things that are further out. It's where most of our comets come from, and that's really more of a sphere of really highly inclined things all around us. So there are some inclined Kuiper belt objects, but it's much closer aligned to the plane of the planets for the most part.
Is New Horizons still sending data back to Earth?
I'm pretty sure, yeah. Last I checked, anyways. It's not like we're getting nice images back, but things like the dust counter still work, which I think is pretty neat to track, you know, where all the little dust that we can't actually see is, because that can tell us a lot about, you know, where the dust ends up when everything settles after planets form. Yeah.
Do we know anything about the origin of the Kuiper belt?
What do you mean?
How did it get there? What caused it?
Yeah, so the Kuiper belt would be a lot of things that just formed out there. So when planets form, you know, you've got a disk of material that coalesces into planets. And what kind of planet you get depends on how far it is from the star. So closer in, you can only have rocky planets because those are the only molecules that can be stable at those temperatures, whereas the icy things further out would, you know, sublimate or get blown out to further. And so at the distance from a star that the Kuiper belt is, you've got a lot of these icy molecules. And so they formed these smaller bodies out there. And some of these things formed there and stayed there, like MU69, what we call the cold classicals. But then there are other populations of Kuiper belt objects that are actually things that like scattered around the inner solar system and like the gas giant planets when everything was, you know, there was a time in the solar system's past where everything was a lot more dynamic. There were asteroids flying about. This is, you know, when we got the moon was in that time where everything was still flying around. So in this time of all of this scattering and motion, some things were bouncing around the inner solar system and got kicked out towards the Kuiper belt. So it's a different population of Kuiper belt objects that's out there now, but had a very different past. And we can tell based on like what they're made of and things like that. So some of the Kuiper belt formed there. Some of it is like stuff that might have been small debris that formed in other places of the solar system. But as the bigger planets moved around and shuffled into their final forms, those smaller things got kicked out to the outer solar system by gravity.
And they're held, are they held there then by the sun's gravity?
Yeah. So they're
Okay.
all in like nice stable orbits now for the most part. Yeah.
Okay, thank you.
One thing I was wondering about was the constituents of the atmosphere and also the surface. If I'm not mistaken, it looks as though you're saying that methane, nitrogen, and water and carbon monoxide are the primary constituents. Is that true?
That is correct.
Okay. One thing I was wondering about is is it kind of unusual that you have carbon monoxide instead of carbon dioxide?
Not really. That's a
No?
pretty common thing out in the outer solar system. Yeah.
But won't you expect carbon dioxide there to be present too?
You can
No?
get both.
Yeah.
Yeah, you can get both in the outer solar system.
Okay, thank you.
As we're going to look at exoplanets, and we're looking at these exosolar systems, do we expect to have like a Kuiper belt or clouds? They'll act in the same way as our solar system.
Yeah, we expect other solar systems to have these things. Like any solar system that forms like we think planetary systems form should have a lot of small debris. And so we see some evidence of this actually in dead stars called white dwarfs, where people have actually seen debris from either destroyed planets or like small bodies in the solar system accreting onto that white dwarf, so like falling into the white dwarf and getting burned up. And so people have seen that, which is evidence of there being all these small bodies and dust. We've seen planet-forming disks that clearly show these populations of small objects and dusty things. We really expect, everyone to have this. And another sign of it that's pretty neat is the interstellar asteroid that came through a few years ago, Oumuamua. So this was the, weird cigar-shaped asteroid that like came into our solar system and then like flung out really fast because it was moving so fast. So things like that are basically like asteroid belt and Kuiper belt objects and Oort cloud objects that have gotten thrown out of their own solar systems and are now coming to us. So the universe is absolutely filled with all of these tiny objects and dust. It's just we don't usually think about it because it's not the big fun stuff, but dust and small bodies are one of the most important things in astronomy. They're also the most common.
Any other questions?
Thank you. That was nice.
Yeah, let's have a hand for our speakers. Thank you very much.
Yay!